Have you ever really stopped to think about how an AI learns? I mean, how does it go from a blank slate to actually understanding, well, anything about our world? Today, we're going to do something cool. We're going to build an AI's brain right from the ground up, and we're going to teach it the one language that matters: data. And it all really boils down to one big question. And this is it. This is the core of everything. How does an AI learn the rules of our world from just a few examples? See, an AI doesn't get a neat little rulebook. Nope, it just gets pieces of information, data. And from that super limited view, it has to somehow figure out the grand universal laws that govern everything else. So really, how on earth does it do that? Okay, to get our heads around this, let's use a really simple analogy. It's one that's right at the heart of pretty much all machine learning. We're going to call it the candy jar problem. And it's perfect for showing the huge difference between what an AI gets to see and what's actually out there in the real world. So picture a giant jar of candy. The real, actual mix of colors in that entire jar, that's what we call the true distribution. Think of it as the real underlying rule of the world. But, and this is the big but, an AI never ever gets to see the whole jar. It only gets to see a little handful that you pull out. And we call that handful a sample. Now, that handful could be a little bit misleading, right? I mean, just by pure chance, you might happen to grab a bunch of red candies, even if the jar is mostly blue. And this whole idea leads us to the two big tasks in AI. On one side, you've got sampling. That's when you already know the true mix in the jar and you're just generating a new handful. But the other side, that's where the real magic of machine learning happens. It's called inference. This is where the AI looks at its one little handful, its limited data, and has to guess the contents of the entire jar. It's literally trying to learn the rule just from the few examples it has. All right, so if our AI is basically just a professional guesser, how do we make sure it's making good guesses? Well, we need to give it its very first tool, and that tool is probability. You can think of it as the mathematical language for dealing with uncertainty. So what is it? At its heart, probability is just a number that goes from 0 to 1. That's it. 0 means something is totally impossible. 1 means it's absolutely 100% certain. And everything else in the universe is just somewhere in between. This simple idea is the foundation that lets a machine navigate a world that is definitely not just black and white. And you see this in action every single day. I mean, think about your email spam filter. That thing is a probability machine. It scans an incoming email, sees words like free or you're a winner, and it calculates the probability that this email is total junk. If that number gets high enough, let's say over 90%, then poof, off to the spam folder it goes. It's not a guarantee, but it's a really, really good guess. All right, so our AI can make educated guesses. That's a great start. The next skill we need to give it is pattern recognition. Because here's the thing, data out in the real world, it's not just a bunch of random noise. It actually follows predictable shapes and patterns all the time. So let's look at a couple of the most important ones. So there are two really fundamental patterns you'll see over and over. First up is the Bernoulli distribution. This one's super simple. It's for anything that has only two possible outcomes. You know, yes or no, buy or don't buy, click or ignore. Then you've got the famous Gaussian distribution, which most people know as the normal distribution. This describes stuff on a whole spectrum that tends to bunch up around an average, creating that classic bell curve shape. Let's see this Bernoulli thing in action. Imagine we're watching 1,000 customers go through an online store. And let's say we know for a fact that the true purchase rate is exactly 70%. Well, in our little simulation, our sample might look like this. 708 people actually buy something, and 292 leave with items in their cart. See? It's not a perfect 700 and 300, but it's really, really close. That little difference, that's just the randomness of our particular sample. And that Gaussian distribution, the bell curve, well, there's a reason they call it normal, because it is everywhere. Seriously, human heights, IQ scores, test results, daily temperatures. So many things in nature and society naturally fall into this bell curve shape. You could almost say it's one of nature's favorite patterns. Now, this pattern gives us an incredibly powerful shortcut, almost like a cheat code for understanding data. It's called the 68-95-99.7 rule. And what it tells us is that for pretty much any bell curve you find, about 68% of all the data will be within one step, or standard deviation, from the average. About 95% will be within 2 steps, and almost all of it, 99.7%, is going to be within 3 steps. It is such a useful rule of thumb. Okay,
So far, our AI can look at one variable at a time. That's pretty good. But the real world is way more complex than that, right? Things are connected, so it's time to level up our AI's brain. Now, we're going to teach it how to understand the relationship between two different things, how they move together.
And the tool for this job is called covariance. All it is a single number that basically tells us how two things are related. When one of them changes, what does the other one usually do? Does it go up? Does it go down? Does it not care? Covariance is the key to unlocking those hidden relationships in the data.
So, a positive covariance. That just means that as one thing goes up, the other one tends to go up too. They move in the same direction. The classic example is height and weight. Generally, taller people tend to weigh more. If you were to plot this on a chart, you'd see the whole cloud of data points tilting up and to the right.
Then you've got negative covariance, which, you guessed it, is the exact opposite. As one thing goes up, the other one tends to go down. They move in opposite directions. Think about price and demand for a product. As you raise the price, the number of people who want to buy it usually drops. That data cloud would be tilting down and to the right.
And then, of course, sometimes there's just nothing. No linear relationship at all. That's what we call zero covariance. I mean, think about someone's shoe size and their IQ score. They're just not connected in any meaningful way. The data cloud here would just look like a big, random, circular blob. No tilt, no direction, nothing. Oh, and just a quick side note here. You've probably heard the word correlation before. It's basically the exact same idea as covariance, but it's been standardized. It's squished down, so it's always a number between -1 and +1. This just makes it way easier to compare the strength of different relationships. It's like having a universal measuring stick.
So, we've given our AI some pretty powerful tools now. It can guess, it can see patterns, it can understand relationships. But there's one final, crucial principle that ties everything we've talked about together, and it explains the incredible power of what we call big data. It's called the law of large numbers, and honestly, it's super intuitive. All it really says is this: the more handfuls of candy you pull out of that jar, the closer your guess about the whole jar is going to get to the real truth. It's that simple. More data leads to a better guess. Okay, let's watch this happen. Remember that 70% purchase rate from our online store? Imagine our AI is trying to figure that out. So after watching just 10 customers, its guess might be something like 68%. You know, it's in the ballpark, but it's not great. But now, let's give it more data to work with. What happens after it's seen 1,000 customers? Well, now its estimate gets a lot better. Maybe it's up to 71.2%. All that weird randomness you get from a tiny sample size is starting to wash out. And what about after 100,000 customers? Boom. Its estimate is now 70.01%. It has gotten so close it's almost perfectly converged on the true rule of the world. This is why AI and machine learning models are so incredibly hungry for data, because more data is what allows them to get closer and closer to the truth. And this leads us to a final, really critical thought to leave you with. We've seen that an AI learns the rules of the world based only on the data we feed it. Its entire concept of reality is built from the examples it sees. So let me ask you this. What happens when the data we provide is biased? What happens when our handfuls of candy only come from one side of the jar?